So good evening, everybody. My name is Catriona Steele. It's a real pleasure to be here to talk about an article that we published recently, and I'm seeing some familiar names show up on the screen. I haven't done this before, so hopefully it will go smoothly. We asked ahead of time for questions to come in, and there have been just a couple, so I think it makes the most sense to start with that, but maybe just by way of introduction first. I'm going to be talking about a paper that we published about 6 weeks ago in the Journal of Speech Language Hearing Research called Reference Values for Healthy Swallowing Across the Range from Thin to Extremely Thick Liquids. And this is first output in an R01 grant funded by the National Institutes of Health, where what we're trying to do is understand how swallowing physiology changes across different liquid consistencies. And what's different about this project than previous studies that have been asking that question is that this time we're using the International Dysphagia Diet Standardization Initiative framework to define different levels of consistency. And so, as it were, we're trying to develop a new physiological textbook reference regarding what U.S. clinicians should expect to see when you change consistency with your patients. We're starting with the framework of healthy youngish adult individuals, meaning people under the age of 60. And the larger grant is moving on, and we're already well underway to looking at healthy older adults over the age of 60 with an identical protocol, and also to ask very similar questions in a variety of patient groups. And so you can look forward to those results as time goes on. So I'll just also start by wanting to point out that no research project happens with one person alone, and there's an army of people who've contributed to this work, particularly the trainees and students and research assistants in my lab who are co-authors on the paper. So in terms of the questions that have come in already, Daniel asked a few questions yesterday, and I think it makes sense to start with his questions in order. The first thing he asked was about sip size, and he had two questions about that. The first thing he was curious about, or one of the things he was curious about, was whether people take similar sip sizes for barium than they would for non-barium liquids that we're trying to represent. And we've been studying sip size for some time in my lab, and we use a protocol across studies where we give people a cup filled with either 40 or 60 milliliters of liquid, and we ask them to take a natural, comfortable sip. And we weigh the cup before and after that sip. And then we take the difference in weight, and from that we're able to derive an estimate of the volume of that sip, because we also have information about the density of the liquids that we're studying. So we've been doing this for some time. We've played with different volumes in the cup. We've played with different cup sizes. We've played with, does it matter if you take several sips from the same cup versus individual sips from different cups? And we find that the behavior is very, very consistent. And the data in this study that show that in our healthy youngish adults, that average sip size for a thin liquid barium product falls around 12 milliliters is highly consistent with previous studies that we've done asking similar questions. In terms of whether barium elicits different sip sizes from non-barium, yes, I think it does. So our data on water as opposed to barium suggests that average sip size would be in the range of 15 to 16 milliliters by contrast. And so people probably are downscaling their sips a little bit, perhaps in anticipation of a liquid that they think they're not going to enjoy tasting very much. We don't see variation from first to second to third to fourth sip. And we see pretty consistent values there. And we don't see differences depending on whether we give people a larger volume in the cup, 90 milliliters versus 60 or 40 milliliters. We don't find a difference across taking serial sips from one cup versus taking individual sips from individual cups, which is what we actually did in this study. So I think given the clinical instruction to take a sip, the values we have in this study are quite consistent with previous literature. And I'll just say on that point that, of course, 12 milliliters is larger than many of us would use clinically with our patients. And I think that that's something to consider, that we may be under-challenging people if we stick below sort of that 10 milliliter or natural sip range. I will just mention a previous study where I think the first author was Janice Bennett that we did a few years ago, where we also contrived a situation where people didn't realize we were measuring sip volume in an interview context. And we had a hidden scale under a large glass of water that was available to them. We did find that people tend to take smaller sips when they realize they're being observed. So just the clinical instruction to take a sip seems to result in slightly smaller sips than people would do unobserved. The other question that Daniel had about our sip size data in this study was that we removed the data for one participant who we identified as an extreme outlier, and he was mentioning that this discarding of extreme outlier data is something that he feels uncertain about. Is it common, or it is fairly common, and why does this happen? So I'll just say that when you're collecting a lot of data like we have in this study, a really important first step before crunching any of the numbers is to go through a process of data inspection and data cleaning. And in that process, we do things like plot the distribution of the data. We look at whether the residuals, the differences from the mean, are normally distributed. And that allows us to identify values that really fall far away from the rest of the pack. And when that happens, then a researcher has to make a decision about whether or not to remove. And in this case, we had one participant who seemed to be taking larger sip sizes than the others. Don't know why. And so we decided to replace the sip volume data for that participant with missing values. And that's a fairly consistent and common process. And there are sort of guidelines statistically about how big that difference needs to be before you can justify removing or neutralizing or replacing the data. I'll move on to a couple of Daniel's other questions. He wondered whether the appendix to the paper included pictures from this study. And that's a great segue for me to mention that one of the things we really wanted to make sure we did with this study was to share an appendix explaining the rating process and giving people examples. The examples are in fact largely not from the healthy participants in the study, but from other dysphagia cases in our project. We obviously chose clear images and good examples to illustrate what we were looking at. So we haven't included video examples at this point in time, and that's certainly something I'll take away and think about. And then Daniel asked about the fact that we had some penetration in this data set. And he was curious about that. And in particular, He was curious about our use of the term trace and about when penetration events occur. So I'll just highlight that we had 2 people in this data set who showed penetration more often than an isolated case. One of them tended to have a pattern of 2s on the penetration aspiration scale, and the other had a couple of 5s. And so one might reasonably ask, was that person really a healthy, normal example? And all we can tell you is that they didn't meet our exclusion criteria, which were quite strict. We do try to qualify the airway invasion event, the amount, using a 3-point subjective scale, either none, trace, or more than trace. And yes, that's subjective, and trace, of course, would mean minimal. And I think another thing to mention about our methods is that we have a very strict consensus process for resolving differences in opinion across blinded duplicate ratings. So that's something that could be hopefully reassuring, but I do agree that the term trace is open to interpretation. And finally, Daniel was asking about when penetration occurred, and so what I can tell you is that we have looked at the timing of the airway invasion event, and overwhelmingly the data point to this event happening just prior to laryngeal vestibule closure. So it's an early event, or perhaps laryngeal vestibule closure is a little bit late relative to the bolus arriving in that location. And this is also playing out in our clinical data as absolutely a key explanation for airway invasion, is either incomplete laryngeal vestibule closure or late laryngeal vestibule closure. Jordan asked about our choice of using 20% weight to volume barium concentration, and this is a really great question, and I'm really glad to have an opportunity to speak about this. So in the United States, you're very fortunate to have access to a standardized barium product known as Varibar, and that product comes in a 40% weight to volume barium concentration. That's quite a low concentration or a low density of barium. And what's important about that is that concentrations in the range of 40% and lower are not supposed to leave a coating of material on the mucosal walls of the oropharynx. I sometimes tell a story that I did a video fluoroscopy on myself quite some years ago now. And at the time, we weren't being very careful about mixing our barium. And I was horrified to discover on that day that I had residue in my pharynx that I was unaware of. And I believe that that was because we weren't being careful about the barium, and we were using a higher concentration that was actually coating. I've subsequently done a video fluoroscopy of myself swallowing a low concentration of barium, and I'm proud and pleased to let you know that I no longer display residue with that product. So Varibar comes in 40%, and that was originally selected as a concentration that was clearly visible on video fluoroscopy, but unlikely to coat. So in 2008, a really interesting paper was published in the Dysphagia Journal. These authors were clinicians who were concerned that 40% Varibar appeared to them to be a little bit thick. And they wondered whether this was thick enough to be poorly representative of truth in liquids. And the paper was entitled, "Are We Testing a Truth in Liquid?" And the authors were Fink and Ross. And so what they did was they diluted their Varibar 50% with water. And so they had about a 40% contrast in the undiluted product and a 20 to 22% contrast in the diluted product. And they tested these products in a clinical sample. So they started with the 40% regular Varibar, and they looked to see whether their patients had airway invasion. And if they didn't have airway invasion on the 40%, they then proceeded to give them the diluted product. And what they reported was that some percentage of their patients displayed apparently safe swallowing on the 40%, but displayed airway invasion on the diluted product. And they concluded from this that there may have been some sort of very minor but therapeutically effective thickening in the 40% relative to what they called ultra-thin liquid barium. Now, this study does need replication, and I think that there are some challenges to consider. The most important challenge being the fact that people who do have airway invasion don't necessarily do it on every bolus, and so some degree of the difference across the stimuli could just be variation across repeated boluses. But at the time, I thought the paper had a really interesting proposition. And in Canada, we don't have access to Varibar. And so we were in the business of preparing our barium with other barium products. And so we had an opportunity to choose our concentration, and we decided to go with 20. So that's our rationale. I think the other thing to mention is that we now know that using the IDSI test, that 40% Varibar tests as thin. And so it remains to be seen if we were to do a direct comparison of 20% to 40% Varibar, whether we would still see differences. And indeed what other differences might occur. And then I think it's important to say that there could be differences across products as well, barium products. They're not just barium, they have other ingredients in them, and so those are questions that need to be resolved. Jordan also asked what the implications were of the effect size measures in our paper in terms of translation to people with dysphagia. And this is a great question. Effect size is a measure where you take the group mean difference and you divide it by the pooled standard deviation. And the larger the resulting value, the higher the effect. The effect sizes reported in this paper are simply for contrasts within our participant group across consistencies, for example. And so at this point, we can't say that they mean anything about translation to people with dysphagia in terms of expected effect size. We certainly hope that some of the effects that we see in healthy people will be similar in people with dysphagia, but that's a hypothesis to still be confirmed. And we hope to be able to bring you some of that data in the next little while. Moving down my question list, I see a question from Michelle. Hi in Australia. The question is about the palatability of barium and water and the impact that might have on sip size. And certainly I think palatability is one explanation for why people might take slightly smaller sips with barium than they do with water. I also think that as clinicians, we're possibly guilty of setting people up to expect not to like barium. So that's something to think about clinically. All right, Michelle, continuing to ask that it would be great to hear more about the ASPEKT rating tool. So the ASPEKT is a method that we've developed. It's really a standard operating procedure for evaluation in our lab. And it's laid out in the appendix to the paper. The question is if whether we could elaborate. So I think that to say there are really two major stages to our ASPEKT ratings. And at the moment, this is a research tool. But what we are working on and hope to be able to bring you before the end of this year is a clinically oriented paper on how to apply what we've learned in our research to the evaluation and rating of clinical video fluoroscopies. So the first thing we do from a research perspective is we actually take a video fluoroscopy and we carve it up into little videos, one video for each bolus. And we do that because then what we want to do is be able to remove biasing information about that bolus. So our raters are assigned a random video. They're not told the consistency. They're not told whether it's bolus 1, 2, 3, 4, or 5, or so forth. And we assign each video to 2 people for rating, and we hope that they will agree on their ratings. The first thing we ask them to do is count the number of swallows that there are for that bolus. And in this paper, we were interested to see that in healthy people, that on the average 12 milliliter thin liquid bolus was swallowed in a single swallow as a rule, and we had very few clearing swallows. I think that's interesting clinical information. I historically have always thought it was reasonable to allow people a clearing swallow, at least one. And now I'm viewing those clearing swallows with more suspicion as being suggestive of possible problems in swallowing efficiency. We then ask people to identify penetration and aspiration on each and every sub-swallow, what we call those multiple swallows, to tell us which frame they see it happening on, and to code its severity, the 0, trace, or more than trace. And then we ask them to keep going with identifying frame numbers for a whole series of events that we've chosen to try to capture the sequence of swallowing. And that step is the end of the first round of rating. And what we then do is our data manager takes all the data, looks at those timing measures and identifies discrepancies. And we then take those into a consensus meeting and people argue until they agree about when things happen and how severe the penetration and aspiration is. By identifying all of the frames at which those timing events occur, we're then able to do a few things. So we can calculate timing measures between events, and we have chosen to try to come up with a set of timing measures that is parsimonious and non-redundant, and that's in the paper. But then we also have identified key frames in that series of events, from which we can then go into our second round of rating. So we can take a key frame, say for example the frame of maximum pharyngeal constriction, and use that frame for rating the degree of constriction. And by making sure that our raters have agreed on the frame before we do that process, then we make sure that when we rate constriction that everybody's rating exactly the same image. And so in that second round, we do a whole bunch of pixel-based measures using ImageJ. We can track hyoid position. We can look at residue in the pharynx in different locations. We can measure pharyngeal constriction. We can measure upper esophageal sphincter opening diameter. And so those are all in the paper. A couple of other questions that have come in. Ankita asked whether cueing had an impact on the head of the bolus location. So that's a great and important question. In this paper, we made a decision up front that we would not have any cued swallows, that people would just swallow naturally. We have previously published a paper with the first author, Nagy. I think that would have been about 2014, where we contrasted in clinical patients cued, or actually they weren't cued swallows, they were what we called a bolus hold swallow, where we asked people to wait 5 seconds before initiating their swallow versus uncued swallows. And that paper replicated the findings that Stephanie Daniels had previously reported about cued swallows, that the bolus head does remain higher in a cued situation. And of course that then has downstream effects on measures of things like swallow reaction time, also called stage transition duration. Kim has asked if I could explain a little bit more about the subswallow term that I used. And yes, this is a great question. So a subswallow in this paper simply means that it is one of several swallows for bolus. So it could be the initial subswallow, the second, the tertiary, the fourth, and so forth. We then also, with our raters, have spent a lot of time arguing about the type of subswallow when it is not the initial swallow. So we make a distinction between piecemeal swallows and clearing swallows. A piecemeal swallow to us is a situation where part of the initial bolus remains in the oral cavity, and on that later subswallow, new material is added to material that might be left behind from the initial or previous subswallow. So we would call that piecemeal, so that there's a division of the bolus in the mouth into more than one part. A clearing swallow for us is slightly different. That is that the whole bolus went down on the initial subswallow, but then there are higher order or subsequent swallows attempting to clear residue from that initial bolus without the addition of new material from the oral cavity. And of course, I'll mention here that when in any situation where we have more than one subswallow for a bolus, then we can no longer quantify the volume that is being swallowed on each of those subswallows. All we know is the volume that went into the mouth in terms of the bolus volume, but the particular swallow volume becomes impossible for us to estimate. Ed says, since we have a bit of time, can I discuss the information related to my findings in the timing measures? Sure. So I mentioned a few minutes ago that we are hoping to develop a sort of clinical application version of this project. One of my goals heading into this project was to try to identify measures or features of swallowing that actually change across bolus consistency as opposed to those that remain stable. And then the other goal is, as we start to look at clinical examples or our disordered samples, is to be able to look at these measures that we've collected and try to pinpoint the key mechanisms that are leading to functional impairment. And I should probably say that, to me, functional impairment is one of two things. It's either airway invasion and or it is swallowing inefficiency with residual remaining after the initial swallow. And so we're on a search to find measures that explain those impairments that are most responsible in our data, with the ultimate goal of being able to help clinicians focus on the most important measures. And so what we envision coming out with is a decision making guide that will walk people through the most likely explanations first. And then if those don't seem to be explanatory, then we will be able to point you to the next ones. And so timing measures are important to me. One of the things I love about timing measures is that they're actually measurable, as opposed to subjective. And of course, you have to have very clear definitions behind each of the events that you're identifying. I would say that at the moment, the key mechanisms that are emerging from our data are indeed either incomplete laryngeal vestibule closure or late laryngeal vestibule closure, meaning a long laryngeal vestibule closure reaction time, that interval between the onset of the hyoid burst and achieving laryngeal vestibule closure. And there have been several people focusing on this. In fact, Ionessa Humbert has some papers pointing to these as key predictors, and a recent paper by James Curtis also, I think, points to this mechanism. And so measuring laryngeal vestibule closure reaction time may be one of these measures that we will end up recommending to clinicians. Interestingly, that is these timing measures before laryngeal vestibule closure is achieved, both swallow reaction time and then subsequently laryngeal vestibule closure reaction time, are two of the timing measures that were sensitive to the influence of bolus consistency. So swallow reaction time became longer with thicker consistencies, and laryngeal vestibule closure time actually became slightly shorter, and quite what that's about still remains to be confirmed. So there are other timing measures, though, that don't seem to change across consistency, and indeed may not be so explanatory for dysfunction. So we hope to come up with an efficient set of measures for people to help them decipher what's going on, but also then to point them to evidence in the literature about interventions that they might want to try based on the mechanisms that they've identified. So if laryngeal vestibule closure reaction time, for example, is long, then I would be thinking about a chin down position as something that might influence that measure. So that, I hope, gives you a sense. In terms of efficiency, the number one predictor of residue across our data sets, this one and also the clinical ones that we're playing with, is poor pharyngeal constriction. And I just see a question from Jordan about tongue-based retraction, which is perfect in terms of this particular issue. So it's important for me to say that pharyngeal constriction, or the frame of maximum pharyngeal constriction that we identify, is late in the sequence of events. It's after UES opening, and it is an event that chases the bolus down through the pharynx. We don't really know whether it pushes the bolus per se. In fact, I think that the evidence is probably pointing more to it not pushing the bolus, but it is thought to be responsible for cleaning up any material that's left behind. This event, I think, is different than the event that people are calling tongue-based retraction, because the contact between the tongue base and the posterior pharyngeal wall happens earlier in the sequence. And we have talked a lot about this in our lab, and we thought, well, let's make sure that we are clear. Let's go back and try to trace and identify the frame of tongue base contact to the posterior pharyngeal wall. And we found that we have really struggled to do that because the bolus is usually hiding the event on a lateral view X-ray. And so I would say that in cases of poor pharyngeal constriction, then it's interesting to look at relatively where anatomically the defect is located. Is it in the oropharynx, so that region of the tongue base? Is it in the mesopharynx around the larynx, or is it lower in the hypopharynx? And to perhaps try to delineate that and classify that. Or is it more than one of those? And so that's work that we will continue to look at. And Jordan, in this method, the constriction is only traced in the lateral view. So that is a distinction from the approaches used in the MBS-IMP. And so whether the events that we are tracing are comparable to some of the parameters in the MBS-IMP is still something that I think needs to be further explored. Melanie asked, were we surprised to find that post-swallow residue wasn't increased with thicker liquids? Yes, I think I was surprised by that, and it's still something that I'm really intrigued by. There are a couple of things, though, that make the question still confusing. First of all, I should mention that the data in this study are only xanthan gum thickened liquids, and so it still remains to be seen whether starch thickened liquids behave similarly in terms of residue to xanthan gum, and we have just run a comparison of that, and it does appear that certainly with mildly and moderately thick liquids, that starch thickened stimuli tend to leave more residue than comparable xanthan gum stimuli. The second thing, though, that is really a confound in this particular study around that is the fact that the sip volume went down with the thicker consistencies, and that's because we gave people a spoon with which to serve the moderately and extremely thick liquids. And we chose a teaspoon, which is 5 cc capacity, and so the volume dropped. And so going forward, we need to do some more work to look at whether these changes in residue, or the lack of changes in residue, or the lack of changes in pharyngeal constriction are more related to sip volume than they are to consistency. And I really don't know which way that's going to play. Oh, another comment that occurred to me based on your questions that was triggering a comparison between this method and the MBS-IMP. Just to say that down the road we also hope to speak to protocol, meaning what's an adequate sampling of boluses and consistencies to come up with an analysis of somebody's swallowing. And so there are a couple of sort of conceptual differences that versus what is used in the MBS-IMP. The first thing to say is that Dr. Martin Harris's approach uses a whole range of consistencies and tasks to establish this frame of impairment or function. In our approach, we limit that context of reference to single sips of thin liquid. And then we view everything else, whether that's larger sips or continuous sips or texture modification, as something that is a modification of that reference task and a potential intervention. And so that is one conceptual difference. The other thing to say, though, is that we have now collected quite a bit of data with multiple boluses of thin liquid in the protocol. So in this study, the healthy people, I believe, did 3. But we have another clinical study that we published earlier this year in the Dysphagia Journal where our participants swallowed 6 comfortable sips of thin liquid barium, exactly the same product as used in this study. And what we found in that clinical study was fascinating. We found that 8% of our sample showed airway invasion, a PASS score of 3 or higher, on the first bolus. And then if we took them out of the mix and looked at the second bolus, 7% new of our sample showed their first occurrence of airway invasion on bolus number 2. And then on bolus number 3, there was another group, I think it was another 3%. And then on bolus number 4, there were another 2 or 3%. And then it seemed to start leveling off, so that between 4 and 6 boluses, we had caught the 20 to 25% of participants in that sample who displayed an airway invasion problem on thin liquid. Now, Jordan Hazelwood has looked at the MBS-IMP in terms of the different tasks and the degree to which they reveal impairment. And the task that reveals the most impairment across the parameters of interest is the sequential large volume thin liquid task. But if you look at the data in that study, the one that reveals the most problems next is in fact the single sip task. So our clinical data would suggest that only doing one single sip is going to miss some people who have airway invasion problems. And so our conclusion from that is that that task needs to be repeated, and our current recommendation would be up to 4 times. So if you see airway invasion on the first bolus, then you found it. But if you don't see it and you want to rule it out, we think you need to keep going. And so there's room in the MBS-IMP to repeat tasks for sort of clinical probing. And this would be one of the things that I would personally suggest requires a little bit more exploration in patients. The question is, what do I make of the fact that pharyngeal area at rest was significantly different between males and females using the C24 to anatomical scalar? Thanks for asking this question, James. So I should explain that we measured the area of the pharynx on the frame of maximum pharyngeal constriction. And we find that frame by itself adequate for characterizing the degree of constriction. We don't find it necessary to compute a ratio as proposed by Dr. Leonard. And one of the things we like about the fact that we don't have to compute a ratio is that it removes some variability across measuring more than one frame. However, we are interested in the possibility that some people may display more dilation in the pharynx. Dr. Leonard has suggested that this is something that occurs with age. We've also been interested in looking at whether some patient groups display swelling and narrowing of the pharynx, for example, post-radiation. And so we have been interested to measure pharyngeal area at rest. And at the moment, our convention has been to identify a late frame that we call swallow rest, right at the end of the swallow, and to measure pharyngeal area on that frame. This convention is different than Dr. Leonard's convention. You may know that what she does is she takes a single measurement of pharyngeal area at rest at the beginning of her protocol. And to standardize across people, she has the participants hold a 1 milliliter bolus in their mouth in a static position, and it's on that frame that they take the measure. I am more and more appreciating the fact that she came up with that way of standardizing this measure, because when we look across different swallow rest frames within an individual, we're actually seeing some variation. And if we had in fact managed to capture true rest, then we shouldn't see so much variation. So this is one of the measures that is still really a question for us. We're interested in things that might impact measures of pharyngeal area at rest. The suggestion that pharyngeal area at rest is larger in males than in females is entirely consistent with MRI data that Dr. Malfenter has published recently. It doesn't worry me that we see that, whereas hyoid displacement or peak hyoid position, when we use these anatomically scaled measures, the anatomical reference neutralizes differences across size in the system that are thought to be associated with sex. So I don't think that the anatomical scalar will necessarily neutralize all sex differences. So I hope that answers that question. If laryngeal vestibule closure reaction time is long, what could be done for treatment? So the first thing is you could try a command swallow, because we understand that it does indeed keep the bolus higher up. You could also try a chin down position, which E.N.S. Humbert has shown helps to normalize the sequence of closing and may make it easier to achieve closure. That maneuver also is thought to narrow the pharynx, and so that may be something to try with thin liquids. You could try different volumes as well with thin liquids. And you could try a supraglottic swallow kind of technique where there's more volitional intention to breathing and swallowing and trying to time the delivery of the bolus relative to the breath cycle. Thickened liquids are also clearly something that could work here. As I said, it impacts the swallow reaction time component of the interval between bolus entering the pharynx and laryngeal vestibule closure. So definitely, I think it is an intervention that can be helpful when airway invasion related to laryngeal vestibule closure issues is a problem. Stella says that she's been using Dr. Leonard's objective measures, and what I'm suggesting maybe developing a clinical application would be another version of looking at VFSS measures. Yes, it would be, and I think that many of our measures are very similar to Dr. Leonard's and are inspired by Dr. Leonard's measures. A couple of differences that may or may not serve to distinguish the work. One is that Dr. Leonard, most of her work involves either a 3 cc bolus, a 10 cc bolus, I think, or a 20 cc bolus. And so sip volume may differ. We hope to be able to provide reference values across the continuum of consistency with a link to the IDSI levels, which is different than what Dr. Leonard's barium has been able to provide. And then our barium concentration is different than what Dr. Leonard has used. So those may be issues. I believe she used 60% weight to volume concentration. Easy Pake. Now, I should just mention that Easy Pake comes in a liquid format and in a powdered format, and unfortunately the two are different. And so just saying Easy Pake isn't actually quite adequate. So yes, I think that the other place that our work is a little bit different than what Dr. Leonard has historically recommended lies in the fact that for measurement of pharyngeal constriction and of hyoid, we only focus on a single frame. So we find the frame of peak position and we measure that relative to the C-spine. And we don't find it necessary to look at the excursion, so we don't need to look at where it started or where it ends up on its return. And similarly for pharyngeal constriction, we only characterize constriction on the frame of maximum constriction without computing the ratio as mentioned. James again is asking, as we develop norms for the ASPEKT method, I think we will move to a standard bolus size instead of non-measured SIPs? I'm not sure. What we will do and plan to do in terms of due diligence is to now explore some measured volumes and make sure that we understand the differences that go with measured versus comfortable SIP size. I'm also interested to explore SIP size a little bit more in terms of body size. I think that probably bigger people take bigger SIPs. And so in that sense, a standard volume isn't a similar challenge across people of different sizes. And so those are still questions that I want to explore. There was a question about IDSI level 5. We are currently working on developing standard stimuli to use to evaluate IDSI level 5 minced and moist and IDSI level 6 soft and bite-sized. Of course, mixing those up with barium is going to be a challenge. We're working on it. At the moment, my very creative team has been using a pureed bread item mixed in different degrees with oil. I think olive oil and coconut oil are the two they've been playing with, plus barium. And then we've been playing with flavors as well, so adding cocoa powder and so forth. And we're still really challenged by this and trying to come up with something that will behave like an IDSI level 5 and similarly for an IDSI level 6. Stella asked, when do I think this will filter to the pediatric population? Great question. Well, my expertise and the expertise of my lab has not been pediatric so far, but we are interested in looking at different disorder populations. At the moment, I can't imagine that it will ever be acceptable for us to collect reference video fluoroscopy data in healthy children. But we do have an opportunity coming up to look at a clinical pediatric data set of very young children where there has been more than one consistency routinely tested. And so we're hoping to use that as a pilot exploration of the lower levels on the IDSI framework, thin, slightly thick, and mildly thick perhaps. So hopefully within a year from now we'll have some preliminary data on that, but they won't be healthy reference data. They will be more about documenting differences across consistency and perhaps confirming whether certain parameters vary. And as we move into that, of course, we're going to have to upskill in our knowledge and skill of rating those pediatric videos. I think we're probably at the end. This has been fun. I hope that I've managed to address most of the questions that came in. I'm always happy to receive questions by email. If you go to our lab website at www.steelswallowinglab.ca, you can also send us questions there or our Facebook site. And look forward to interacting with more of you offline.